How's it going, you guys? It's Scott with Everyday Home Repairs, and today I want to walk you through the complete process of installing a sub panel in a garage. Now, I did a little pre-work yesterday, and that was getting the trench dug in. That included cutting some concrete out, renting a 4-inch wide by 24-inch deep trencher, and then cutting the 75 foot of trench between the corner of the house right here and that garage that's behind me. Now, this is an approachable DIY project if you feel safe doing electrical work and you know the code in your area. That is on you to understand your own area. But we got a little help today by Joel Walsman, who runs Jefferson Electric out of Indianapolis, Indiana, and also has an awesome YouTube channel at Electric Pro Academy. Joel's going to show you step by step, and in that timeline you'll see the different chapters of this project, so you're more informed if you're taking on this project yourself, or if you're just hiring it out, just making you more informed so it's easier to work with a professional in your area and get the result that you want for a reasonable cost. So let's jump down in the basement. Joel will show you the panel, and then we'll go through the plan of attack for this project.
We're at the panels. To my right, we have the main electrical panel. Off here, we've got a newer installed sub panel. This is a secondary panel that's been utilized to add circuit capacity because the main panel is full. We're going to bring our installation for the garage circuit off of the sub panel because it's newer, it's in better condition, and it's got the available circuit capacity we're looking for. I'm going to be utilizing THHN wire, which is a wire type to be utilized only inside conduit. I'm using a PVC rigid conduit, exiting the top right of the panel, penetrating framing in 2 places before exiting the band board. I've got brick to go through, so I'll show you that penetration as well and talk about conduit types, wire types, and their proper uses. In this situation, we knew we wanted 60 amps in the garage, so we're using 3 6-gauge conductors, 2 hots and a neutral, and a 10-gauge ground. That's code for this application. We're using 1-inch conduit to accommodate that circuit, and I'll be drilling with a 2-inch hole because the outside diameter of 1-inch conduit is 1 3/8. These are non-structural framing members, so I want a little bit more capacity so I can easily slide my pipe in there because I'm going to have to bend it to fit it in, and I want a little bit of intentional play. All right, when you're drilling a 2-inch hole at that speed, man, you've got to have that accessory handle. The glass pane, window pane is right there. I was afraid of smashing my hand right into that and suffering lacerations. So hand protection, eye protection is an absolute must. Before you remove that last screw, be careful. You've got to be qualified to put your hands in here, hold the cover in place. I like to leverage my forearm, something like that, where I've got a grab on the lip, but I've also got pressure on the cover because that cover can fall towards you, and in an attempt to catch it, you can accidentally shove it back into the live bus. It's really hazardous. Probably best, if you're doing this project yourself, to go ahead and turn off the main breaker before pulling the cover. These are my 2 incoming hot conductors, main neutral. One thing I really like to see in a sub panel like this is this ground. This is a code requirement that the ground conductors are separated from the neutral conductors. And that's one of the most common mistakes made by DIYers. So you'll find that neutrals and grounds are common. They're together in your main panel, but every sub panel, this one and in the garage, the neutrals and grounds will be separated. I want to come in this upper knockout, so I'm going to go ahead and knock it out. Ooh. So the first knockout I knocked out was a 1/2-inch nominal. That's actually a 7/8 dimension. The second one that I'm knocking out here is for 3/4-inch conduit, and that's 1 1/8. I'm going to have to enlarge that hole because I'm using 1-inch conduit, and you can see it's not going to fit. So pro tip, before I pull my panel cover off, I drilled my 2 holes, and that's to keep debris out of my panel. Secondly, before I drill out this hole with my step bit, I'm going to put in a piece of cardboard that's going to help deflect those metal shavings out of my panel in order to keep it clean. Next, I'm gonna trial fit my 1-inch Schedule 80 conduit through the holes I've drilled. I'm gonna locate on the band board with Sharpie exactly where that hole goes. I'm gonna drive a 1/4-inch pilot hole with my SDS Plus, and then I'm gonna come back through from the outside in order to minimize blowout of the brick and have more operating space with the big boy to generate my hole for my pipe. You can drive the pilot hole with your hammer drill that you probably got at home, but this SDS Plus rotary hammer is gonna have so much more punch and is gonna generate that hole much faster. It's also gonna be capable of larger holes. But because of all that punch, it's super loud, so pull out the hearing protection. So I just punched through to the exterior with the solid pilot bit. Now I'm going to use the big boy to go back through and generate a clean hole. You've got at least 3 options for generating a hole like this. You can use a cold chisel and a 4-pound sledge and spend about an hour, but very cost effectively remove that. You've also got the option of the smaller SDS drill and bit, like I demonstrated, and you can drill a series of holes in a circle and then use a cold chisel to finish it out. And that's at least a 30-minute option. Requires a little bit more tooling. Or you can buy, rent, or borrow a big boy like this. This is an M18 2717. It's got a carbide hole saw on the end. This boss will drill holes like this all day long. And that chunk of wood right there is a clear sign that you've made it all the way through. We've completed our hole outside. Now we're back inside. It's time to complete our conduit. I'm gonna dry fit everything, take it apart, glue it up, put it back together, strap it up, and we're back outside running conduit to the garage. I had a little bit of trouble getting the lock nut on there. I like being in the corner and to the back as often as possible to leave as much free space for additional future circuits, but you might want to move it one over to avoid the obstruction at the side of the panel. Now I'm going to secure and support my conduit. That's found in Article 352 of the National Electrical Code. The basics are this: within 3 feet of the termination, there needs to be a support, and then approximately every 3 feet after that, but it does depend on the size and type of conduit. So make sure you reference specifically what you're doing. In our situation with 1-inch PVC, it's every 3 feet, no exceptions. A little wire prepping tip. I talked about THHN. That's the type of single conductor wire that this is. It does not have an overall outer jacket like Romex. The conduit is the outer jacket. This is going to be a smooth, clean, simple pull through the conduit. A cable like Romex, one, cannot be in an exterior conduit or an underground conduit. That's a big no-no. That's a wet location. This conduit is not going to be watertight or airtight, and it will be considered by code a wet location. So I'm using a THHN or THWN. That W is for wet wire in the conduit. And let me show you how to make your life easier. I'm going to spool it off by keeping it nice and straight. Nice and straight and smooth. I'm going to feed that, and that straight run is going to pull through the conduit so much more clean, because I'm right at 360 degrees of bends in my conduit between pull points, and that's the maximum code allowable number of bends between pull points. So I'm going to experience a lot of resistance. Peeling it off straight like this and feeding it off is the cleanest, smoothest run possible, and it's going to pull through the conduit so much better. And let me show you what to do if you have pigtails like this red one. You start playing a little cowboy and take the twist out of it. All right, now instead of using a 90-degree fitting to come out of the house, and being way off the building, unable to support my conduit, I'm gonna use an LB. This is an L-shaped conduit fitting with the opening on the back, as opposed to an LL or an LR. This conduit fitting, I'm gonna soften my pipe, mount it to the house. I'm gonna secure my pipe within 3 feet of both sides of this. 1, strap on the inside, 2, strap on the outside, and that's gonna properly support the fitting so don't get movement or breakage. Every joint is the most fragile point on your conduit system. I want that to be tight and held rigidly in place. The pipe that's exposed, both inside and outside, is gonna be PVC Schedule 80. And that's a heavier wall pipe. It's almost double the thickness of Schedule 40, and it's designed for exposed locations and to resist physical damage. My underground pipe is gonna be Schedule 40. That's got a larger interior diameter, which means an easier wire pull, and is more cost effective as well as being lighter weight. All right, because of the offset in the brick here and the offset in the Mini, I've created a little PVC custom spacer to bring my conduit in line with my LB. When gluing your conduit parts, it's always best to glue both the socket and the hub if possible. You're gonna get an easier fit. It'll slide in there that much better. But always at least glue your hub, in my opinion. And then give it a twist. Smear that glue around so you get even distribution. The PVC glue is really intended in electrical installations for a mechanical hold more than anything else. If you weren't clear before now, let me make it clear for you. This is the suckiest part of the job right here. We had 4-inch nominal concrete to cut through. That required, Scott actually borrowed it and did the work himself, but that was a $150 rental per day concrete saw to cut through that, and then bust it up with a sledgehammer and haul those chunks out, and then concrete repair on top of that. It's laborious to the max. And then you've got the RTX 150. That's a 4-inch wide by 24-inch deep capacity trencher. That was $252 with the trailer from the local rental store. Do not underestimate your local rental store. Those guys will drop the knowledge bombs on excavation and earth moving and best practices and local connections close to your zip code all day long. They're great at this, and you can save so much money. Don't buy $500 tools, just rent them for $50, $100 a day. Send them back, they do the repairs, they house them. Oh, beautiful. All right, after you've got your trench, and let me tell you what, this is one of the magic pieces of the trench, this trenching shovel. The angle is better. It's only 4 inches wide. You'll move less dirt. This thing will save you a ton of effort. Your trench for conduit by code needs to be about 20 inches deep because you need to have 18 inches of cover. That's dirt on top of your pipe. 18 inches of cover. What I do is I measure and mark a spot on my shovel so I can just stick it in the trench, and I've got an automatic depth finder so I'm not pulling out my tape measure, wasting time. Now, the angles are not absolutely precise. If I don't have a true 90-degree angle, I'm gonna use this heat gun, heat it up and bend it a little bit, and if it's 80 to 110, I'm gonna be totally fine there. Another thing is, now here's the pro tip. This is really important, but it gets a little bit nerdy. Don't lay your PVC conduit in the sun for too long. It will actually expand. PVC has a substantial expansion coefficient because if you lay it in the sun and it expands, you install it in the trench, and then because we're above the frost line, that conduit will freeze. It will literally be less than 32 degrees, which means it's gonna contract substantially. And when you get that substantial contraction, it pulls itself apart. That's an irresistible force. Your wire becomes exposed. It'll expand again when it heats up, it'll contract, your wire will be destroyed, your conduit path will be incomplete. So try to maintain the temperature of your conduit at an equilibrium. Mine's sitting in the shade right now. I would put your wire in the sun because that'll soften it up. We're not concerned about the same thing, but put your conduit in the shade and then just force it to the contours of the trench. You could break it, but it's pretty durable. So Schedule 40 in the trench with 18 inches minimum cover. It's different for direct barrel. That's 24 inches of cover by code. Now I'm going to complete my conduit system from here through the trench to the garage and set my sub panel. Then we're ready for pulling wire. I'm going to lay some pipe in the trench, but let me call attention to a clay tile here. This is something that if you're not head on straight, really paying attention, looking for the cues, can make this an entirely much more complicated project. You, the individual contractor, homeowner, you are responsible for calling for public utility locates. And they're gonna locate water, sewer, gas, electric. But only the public utilities. All private utilities are off. That's on you. This is a clay tile. This would not be found in a utility locate. The way Scott found this is there's a storm drain over there. It exits at the street over here. He put 2 and 2 together, did some hand digging, found the clay tile, exposed it. Absolutely on point. There's a storm cistern over there. We hit an unknown underground 12 gauge conductor back there. Irrigation systems, PVC, non-metallic, things of that nature will not be found in a locate. The only way to find an irrigation system is if you have a map from the installer. You just have to cover your liability, know what you're getting into, take responsibility, and have all of it spelled out in a contractual, verbal arrangement of some kind, because this right here, that's easily a 4 to 8 hour cleanup project and a few $100. So I've completed my underground conduit system. I've got a total of 3 LBs, respective polling points to get the wire through to this location. I've bored through, my grounding system is nearly complete at every separate structure. The National Electrical Code requires 2 ground rods, more than 6 feet apart, bonded together to the panel with the appropriate sized conductor. There are tables for that. Consult your local inspector and jurisdiction about all of these details because there's finesse and not just code to all of it. Now, we're going to be installing our sub panel. This is an 816, meaning 8 circuits, 16 spaces. It's compatible with Space Saver breakers. We've selected Square D Homeline because that's the same sub panel type that we have in the house. So it just makes it easier, minimizes the number of breaker types. It's a main lug. We did add the ground bar to separate grounds and neutrals like we talked about in the house. And I'm going to use Tapcons to secure it. One thing you may have seen is plywood on a masonry exterior wall. That's not required by code in this situation because we've got 1/4 inch standoffs. That's the bumps on the back of the panel that'll create the separation and that air gap to prevent corrosion of the steel enamel. In case you're wondering, off to the right, you're going to see major tools and equipment that we've utilized in this video. And in the description down below, you'll get the total material list to help you get started on your project. Best practices. At this point, I've got a total of 4 conductors to pull through, 2 hots, neutral, and a ground. I'm going to stagger the ends of those conductors a little bit so that I'm not creating one big knob that's going to catch on the fittings through the pipe. And then I'm going to double up my ground so I've got a good solid hook, and it's going to be taped all the way back. I don't want that pulling out free from the rest of the conductors to where they're left behind. And I've got to pull everything out of the pipe. It's got twists and tangles in it. It's nasty, ugly mess. You have to get this right. There's going to be a ton of resistance on a 360-degree pull. Like 1 or 2 guys, full force pulling kind of resistance. You've got to lock this in as tightly as possible. And this is exactly where electrical tape is notoriously beautiful. It's got that stretch which applies tension to the conductors and prevents pullout. Don't try any other kind of tape. You have to use a good quality electrical tape like Scotch 88. And here's what the finished product looks like. All right, if the trench was the number 1 suck, this is the number 2 right here. This is a 2-man job. We are pulling 6-gauge conductors through a 1-inch conduit over 70 feet, all of 360 degrees of bends. That 360 max, that is a practicality. The resistance on your wire in excess of 360 is insanity. This is a 2-man job. We're going to pull through the main segment of the trench through our LBs. This is exactly why you have LBs, pull points, in order to access and minimize the number of bends you're pulling through. And then we're going to terminate the sub panel and then terminate wire into the house. That'll be an easy push in on each end, but this main 70-foot pull, ooh. I want to be feeding as Tim is pulling. Keep the conductors from kinking up. You can use wire lubricant, which makes the job easier, but this simple stuff, it's designed to be pulled without lubricant, but it's gonna be beastly. Okay. Hold it. Okay. Get that bad. Pause before that. We'll just. There it is. All right, keep going. Enough to get us into the sub panel and terminate it. I'm close to 10 feet. We got plenty over here. So we just accomplished that 70-foot pull. Wasn't as hard as I thought. We shoved it through the little bit of exterior conduit, ready to pop into this panel and make our wiring terminations. Now you might be asking, but isn't this panel upside down with the main terminations on the bottom? And the answer is no. The only thing that makes a panel upside down is if it's rain tight and it's inverted, because it's no longer rain tight, loses that NEMA 3R rating, or if a breaker is down in the on position and off in the up position, that's a code violation. But these are terminals that can be oriented in either direction, and my breakers move side to side. So I'm fully code compliant, and I've minimized the amount of wire that's required inside the panel and the amount of congestion from my main conductors coming in and terminating on the top. It's a little simpler, a little cleaner. Send them in, Tim. Here's one more little trick. See how I've doubled over that conductor? That's to prevent it from snagging on my bushings and fittings. And then I'm going to pull one at a time until they're all nested into that LB. Terminating my conductors. It's white to the neutral bar. Just follow the logical chain and look for clear labeling. Black, phase 1, red to phase 2, and ground to the ground bar. That's it. And then respect your torque settings that are posted here on the inside label. And if you can, use a torque wrench. 25 inch-pounds in this case for ground bar, 50 inch-pounds for 6-gauge on the main conductors. All right, small little push inside, patch the holes to prevent water infiltration on both ends, and this part's easy. Terminate the breaker, energize, test for power. Oh, look at that, that's
Beautiful, beautiful.
We're rocking that breaker into place. Want to get a firm seat. Always want to have breaker panel brand compatibility. So Square D Homeline, Square D Homeline. One of the things that's really important here with these larger stranded conductors is the wiggle, loosen, tighten method. So you're wiggling those conductors, those strands, those fibers are settling into place, mashing into place because they're spiraled inside the jacket. So you're tightening, you're wiggling, you're loosening, and you're retightening down to torque spec to get the optimal connection. And if something's going to fail, it's going to fail at a wiring connection. So let's make up our terminations here. So remember, the entire panel is de-energized except for these main two lugs coming into this breaker. Now what I'm doing here is considering that this is my A phase. So this is phase A, phase A, phase A, and then this one right here is phase A. So standard color coding is phase A is black, phase B is red. And I'm going to hold true to that, although there's nothing I'm going to screw up. It's just a minute detail of quality workmanship. Uh-oh, a little bit of a mistake here. This is a sub panel. Grounds and neutrals have to be separated. So I'm going to put my neutral, pull it off the ground bar, which is incorrect, and move it over to my neutral bar, which is the correct location. We did turn on the 2-pole 60 amp in the house, plus the sub panel. Now it's time for validation to ensure that our work is good. We've got 123 volts, hot to ground. Move my gator clip. 122.5, hot to ground. Nothing, neutral to ground. And we just want to make sure we've got 240 nominal. The service is running a little bit hot. Hot to hot, we're at 250, dancing around a bit, hot to hot, that's good. So to get to this point right here was $800 in materials and $300 in rentals. It's $1,100 for a DIY. If you're hiring out to pros, you're probably $4,000 to $6,000 because of the intense labor on the trench plus the technical aspects. From this point, all of our projects diverge, but one thing we have in common is an outlet to make everything else easier and to facilitate the rest of the project. So for that, click on this video right here. Thanks for joining, and we'll catch you next time.